All right, let's just dive right in, because today we are unpacking Chapter 5, Understanding Data. We're going to pull back the curtain on how raw, chaotic numbers and text are basically magically transformed into the actionable decisions that drive our entire modern world. So if you've ever wondered how the digital world actually makes sense of everything, well, you're in exactly the right place. To really set the stage for this explainer, I want you to listen to this incredible thought from Gary Schuber. He says, data is not information. Information is not knowledge. Knowledge is not understanding. Understanding is not wisdom. I mean, wow, right? Having massive, just overflowing amounts of raw data really isn't enough on its own. Data is literally just the starting line. It's what we do with it that actually gets us to wisdom.
So here's our roadmap for the life cycle of a single data point today. We'll start with the world of data, move into structured versus unstructured, then collection and storage, the data processing cycle, measures of central tendency, and finally, we'll wrap up with measures of variability.
All right, Section 1, the world of data. Let's talk about the data we generate every single day.
Just imagine the sheer volume of data being generated right this very second. Every tap on your phone, every weather satellite up there orbiting the Earth, every single scan at the grocery store checkout. It's literally everywhere. But what exactly is it? Well, formally speaking, data is a collection of characters, numbers, and symbols representing values of situations or variables. And hey, fun fact you can use at your next trivia night, data is actually a plural word. Yeah, the singular form is a datum. So we collect all these datums, or data, because, well, they're the raw fuel we absolutely need to make informed decisions.
It is actually incredible how relatable this becomes when you bring it down to an everyday level. Think about choosing a college, right? You're looking at placement stats, faculty experience. That's all data. When you withdraw cash from an ATM and your account balance updates instantly, data in action. Or when your phone suddenly buzzes with a heavy rain alert triggered by a satellite, that's meteorological data, literally keeping you safe. Data drives our daily lives, plain and simple.
Moving right along to Section 2, Structured versus Unstructured Data. Let's look at the actual shapes this data takes.
So before we can even process all this information, we really have to understand its shape. And we basically have two main camps here. Over on one side, we have structured data. This is the highly organized stuff. Think of your classic tabular formats, like spreadsheets with those nice, neat rows and columns. But then on the other side, we've got unstructured data. This has absolutely no fixed pattern. Think about the crazy layout of a newspaper page, a long rambling email, a video file, or just a photo on your phone.
Take a shop's kitchen inventory, for example. Look at how beautifully organized this is. With these distinct columns for unit price and items in inventory, a shop owner can just fire up a spreadsheet, multiply those two columns together, and bam! Instantly find the total value of their melamine plates or water bottles. I mean, you definitely can't do that easily with a messy, unstructured text message, right?
But wait, what do we do when data is unstructured and messy, say a photograph or an email? Well, that's where we bring in something called metadata. And metadata is, quite simply, data about data. It's like the little descriptive tags attached to the mess. So for an email, the unstructured part is that massive paragraph of text, but the metadata? That's the subject line or the recipient's address. For an image, the metadata would be the file size or the fact that it's a JPEG. It just helps bring a little bit of order to all that chaos.
Okay, Section 3, Collection and Storage, because we have to safeguard all this data we're generating.
Look, data is completely useless if we don't actually capture it and keep it safe somewhere. And collection has evolved so much over the years. I mean, it can start as simply as a grocery store owner writing down their daily sales manually in a physical diary. But today, we're usually capturing data digitally. We store it in simple CSVs, those comma-separated values files you've probably seen, or, for the really big stuff, we rely on custom software, massive hard disk drives, solid-state drives, and heavy-duty database management systems to securely house everything so we can easily pull it up and update it later.
Which brings us to Section 4, the data processing cycle. This is where we start making all that data useful.
Because let's be real, just safely storing data on a hard drive is really only a pit stop. Now we actually have to process it to learn something valuable. And the automated processing cycle boils down to three really straightforward chronological steps. Step 1 is input, Step 2 is processing, and Step 3 is output. Let's actually see how this plays out in the real world. Let's completely demystify an ATM transaction using these three steps. So your input is just you typing in your PIN and requesting a specific amount of money. The processing, well, that happens entirely behind the scenes. The bank system verifies your login, double-checks if you actually have enough money, and then deducts the balance. And finally, the output is the physical cash dispensed into your hands plus that printed receipt. It's literally raw data magically becoming a physical, tangible result.
All right, moving to Section 5, Measures of Central Tendency. Let's talk about summarizing all this data. So when you have thousands and thousands of rows of processed tabular data, you absolutely need a way to summarize it into just one easily digestible idea. And the three most common measures of central tendency give you the perfect mental toolkit for exactly this. You've got the mean, which is simply the average value. You've got the median, which is the exact middle value when you sort your data from smallest to largest, and then the mode, which is just the value that pops up the most frequently. Instead of staring at every single data point until your eyes cross, these three little techniques tell us the core story of the entire dataset.
To put that into perspective, take an average height of 101.33 centimeters for a class of just 9 students. To get this nice, clean number, we literally just added up all 9 of their individual heights, which gave us 912, and then divided that by 9. And just like that, boom, one single number tells us the story of the entire room.
But, we really have to be careful here. The main danger of relying solely on the mean comes in the form of an outlier. And an outlier is basically an exceptionally large or small value compared to the rest of the group. Imagine if one student in that 9-person class was randomly 7 feet tall. Our average would shoot way up, totally misleading us. So when your data has massive extreme outliers like that, the median, literally just picking the middle number in your sorted list, is often a way safer, much more accurate choice to find the true center.
And that leads us to Section 6, Measures of Variability, because finding the center is only half the battle. We also need to understand the spread. So we know how to find the center, but what about how spread out everything is? Think about it. 2 completely different datasets can have the exact same average but look totally different in reality just because of how scattered the numbers are. To understand this spread, we use measures of variability, and the big ones here are the range and the standard deviation. The range is honestly incredibly simple. It's literally just the maximum value minus the minimum value. Going back to our 9-student class example, the tallest student was 115 centimeters, and the shortest was 85 centimeters. So 115 minus 85 gives us a neat range of 30 centimeters. It's a super quick way to see the total spread of our data from the absolute top to the absolute bottom. But here's the catch. The range only looks at 2 numbers, the very highest and the very lowest. Standard deviation is a much more powerful tool because it actually considers every single data point. It calculates the average square difference of every value from the mean. Now for our 9 students, the standard deviation came out to 10.22 centimeters. A smaller standard deviation just means the heights are clustered really tightly together around the average. A larger number, that means the heights are widely scattered. So it gives us a much richer, deeper picture of how diverse our data actually is.
Okay, wow. Let's take a quick breath and just recap the incredible life cycle journey we just took. We started with all those chaotic, everyday raw inputs during data collection. We organized it all through storage and processing into nice, structured tables. And finally, we uncovered the hidden stories tucked inside that data through summarization, using our trusty statistics like mean, median, and standard deviation.
And that leads us to the ultimate point of this entire explainer. We have the data, we've processed it, we have the statistics, the numbers have spoken. So, what will you decide? Because as we learned right at the very beginning, data itself isn't wisdom. You now possess the tools to conquer the modern data explosion, but at the end of the day, it's totally up to you to make the final call. Thanks so much for joining me on this explainer. Keep learning, and I will see you next time.